Midnight on a high ridge. The dome splits, and a wide camera drinks the sky. The galactic plane pours across the sensor like a crowded river, every pixel alive with stars, dust, and the occasional satellite scratch. In that noise, a quiet ember shifts between frames. It is small, steady, and moving faster than the background can explain. The image is calm. The implication is not. Here is a body racing through our neighborhood that the sun cannot keep. A faint veil clings to the core, just enough to soften the point of light. Sunlight pushes the dust. The tail forms, and the geometry betrays direction long before equations do. The brightening rises as day by day the object falls sunward, yet the light curve hardly wobbles. Quick through space, slow in its own turning. How can both be true at once? If speed writes the script, why does the spin refuse drama? We draw the track from dots on a grid, subtract the background, fit the path. The curve does not close. It arrives from far away, bends near our star, then opens back out toward the dark between suns. That single shape changes the story. A closed loop means family. An open path means a visitor. A visitor means a chance to read a different planetary system without leaving home. Simply put, we have stumbled on a traveler that comes from another star and will not stay. The sun can bend it, not own it. That tells us two things at once. First, there are engines in the galaxy, young and old, that throw small worlds into the deep. Second, our chance to study this one is short. We get an approach, a brief nearest brush, and a receding silence. What can we learn before the page turns? Look closely at what the light says. The nucleus brightens with a discipline that suggests size. Big enough to average out small jets. Big enough to keep the rotation from making wild flashes. There is a hint of red in the reflected glow, as if its skin has been seasoned by cosmic weather for a very long time. The tail is not grand, but it is honest. It points away from the sun like a compass needle set by pressure and wind. We set the scene at human scale. A backyard pier clicks in the frost. Cables tucked under a blanket to fight dew. A desert array hums on the other side of the world. Logging time and coordinates with the patience of a clock. The same point appears in both feeds. Night after night, the position tightens, the uncertainty shrinks, and the sky gives up a little more of its pattern. No single watcher could have done this alone. Together, eyes and instruments turn a rumor into a route. Numbers fall into place with every new night. A speed high enough to treat the sun as a bend, not a boundary. A closest passage set well inside the orbit of Mars. Bright enough for amateurs and professionals to share the work. A rotation that ambles rather than tumbles. If it truly began in a cradle far from here, what nudged it loose? A near miss with a giant planet. A long, slow trade of energy over ages. A burst of early chaos while stars were still wearing their birth clouds. Which history fits a traveler that is old in behavior, yet swift in transit? This paradox matters. A path that never closes forces us to redraw the map of our own system. The count of such visitors reveals how generous star systems are with debris. The nature of the light tells us about ice, dust, and the varnish of time on a surface that remembers a different sun. Each small measurement is a handle on a world we will never touch. Each handle lets us test how planets form, scatter, and clean their yards. Watch the tail again. It is a thin thread, easy to miss if you blink. That thread records direction, and hidden in that direction is memory. Memory of the way it came in. Memory of how fast it must have been when a distant gravity well let it go. If speed points to youth and violence, then this could be a shard from a loud beginning. If speed fits an ancient drift through the galactic disk, then we are reading a page from the long, quiet middle of a stellar life. Which path does this object write on our sky? Here is the plan written by the sky itself. First, fix the orbit so tightly that escape is beyond debate. Next, compare speed and angle with the small club of earlier visitors. to see where this one sits on the scale from quick to astonishing. Then, watch the light for rotation and color, not for spectacle but for steadiness, so we can infer shape and surface without guesswork. Finally, carry those clues back to the question that began the chase. What kind of star, what kind of system, sends a body like this into the deep and leaves it unchanged enough to remember? Hold the opening image, a coal red in starlight, a thread of dust pointing away from our star, a line through space that bends and never returns. If we treat this not as an oddity but as evidence, what does it measure about us? That we have finally built tools fine enough to notice travelers that were always there, that the galaxy is busier than habit admits, that age can move fast and still carry the weight of long memory. We will follow this traveler while it shares our sky. We will map its path with care. We will test its speed against the standards of our neighborhood, and we will weigh its light for size and spin. We will listen for origin by reading what it refuses to do here. And as we do, we will leave one open loop on purpose, because the answer will not fit in a single night. If one messenger writes on our sky tonight, how many more are passing unseen, and how many are already on their way? If careful measurement speaks to you, like and subscribe to the Quiet Universe channel. The night is crowded. The galactic plane pours across the chip like a river of grain, and the software must learn to breathe in that noise. We sweep our searchlight through the fog, frame by frame, subtracting yesterday from today to see what refuses to stay put. A faint point shifts. It is not an impulse from a cosmic ray, not a hot pixel, not a satellite scratch that vanishes in the next exposure. It persists, it moves, it brightens as the nights repeat. We look for the soft halo that marks a comet. Around the sharp point there is a slight blur, a small coma that rounds the edges. The shape is honest under sunlight. The dust lifts. The line of motion begins to read itself across the image without waiting for equations. The tail is thin but consistent. Brightness rises with approach, but not with the skittish jumps that tiny shards often show. The curve holds steady within a narrow band. Calm light over many nights is its first signature. Artifacts can fool a rush of hope, so we go hunting for traps. A single bright pixel can mimic a star if you stare too long. A plane can draw a line that looks like speed. The atmosphere can bloat and shrink the point spread and hide slow motion under seeing. We test each suspicion in turn. The moving dot lands where the prediction says it should, after the sky has been plate solved and the background removed. It respects the calendar. It repeats across time zones. It behaves like a real body that shares our sky rather than a glitch that shares our program. At its core, this is the moment where the rumor becomes a root. The more observatories feed their dots into the common log, the tighter the fit becomes. Longitude and latitude differences sample parallax that a single site cannot. Small instruments on tails of weather fronts fill gaps that big telescopes cannot chase. This matters because early agreement saves precious attention later when the object is faint again. This matters because a shared baseline lowers the risk that a single bias will steer the story off course. This matters because a clean first picture lets us assign time, filters, and people with confidence. We hold the searchlight steady in the fog and take a human step back. Imagine a backyard pier on a hill, frost pushing at your boots, a laptop dimmed to save dark adaptation. The mount whirs, the guider locks, the sequence ticks on. Across an ocean, a desert array is doing the same in a different silence. The same point lives in both feeds. The email that carries last night's positions is not a flourish. It is how this work moves from one set of hands to many. The contradiction arrives in the data itself. Activity is visible, yet the light curve is almost flat. A small, lopsided nucleus should flash and fade as jets rotate in and out of view. Instead, we see restraint. A larger, more rounded body would produce this calm. A mantled surface that leaks in few places would produce it too. Which explanation fits better here? How much of the steadiness comes from size, and how much comes from a skin that has been baked and sealed by time? Another contradiction keeps us sharp. The galactic plane should confuse the measurement, yet the motion cuts cleanly. That is not luck. It is the result of many angles and many clocks. A moving point that is real will follow a smooth arc once you correct for Earth's own pace around the sun. A false one will refuse to fit when you change nights and locations. Our dot fits. Residuals shrink, not expand. When we add more points, the fog is real, and the searchlight is doing its work. The first breakthrough is modest but decisive. The object is not a fixed star misread by poor seeing. It is not a satellite trail caught mid-stroke. It is not a random alignment of noise across nights. It is a genuine comet, with a live coma and a tail touched by sunlight. The flatness of the curve and the ease of tracking point to a nucleus with heft and a rotation that ambles rather than tumbles. That combination is rare enough to be useful and common enough to be credible. We begin the chase. Tracking lists shuffle to give it more time before dawn. Observers agree on a standard set of filters so that color information can be merged instead of argued over. Long runs are scheduled to catch full rotations without gaps that would fake signals. Spectra are planned for the weeks when the signal will be strong enough to clear the floor. The aim is simple. Build a timeline dense enough to tie light to spin, and spin to shape, and shape to history. Why it matters comes into focus as the cadence settles. A solid identification in a hostile field means we can spend effort on physics rather than on chasing ghosts. A stable light curve allows shape and size to be inferred with smaller error bars, which narrows the space of surface models we must test. A networked campaign makes it possible to separate what the comet does from what the sky does, because the sky lies differently at different sites. Each gain is small in isolation. Together, they turn a brief encounter into an experiment with reach. Questions keep the rhythm honest. What else could fake a steady light curve in the face of activity? Could the tail be an illusion of scattered light near a bright field? How certain are we that the point spread differences from site to site are not writing false calm into the data? How many more nights will it take for the rotation signature to step above doubt? We keep to one image, so we do not confuse ourselves. The searchlight in fog is still our guide. We will not swap it for a new picture midstream. The beam sweeps, notes the moving fleck, returns to it again and again, until the fleck's path is no longer a guess. Consistency is our ally. It keeps the chapter from turning into a collage of clever lines and reminds us that the sky rewards patience more than flair. As the measurements accumulate, a new horizon appears at the edge of the field. The path looks more like an open arc than a loop. The speed inferred from night to night is high enough to make binding difficult. The nearest approach will bring the object inside the orbit of Mars, bright enough for many rigs to contribute, close enough for the sun to test its skin. None of that proves origin. All of it prepares the ground for the next question. If the curve is open, then the story is larger than our system. We end where this chapter must end, with the searchlight pointing toward the bend in space that will tell us if the path is a loop or a line that never closes, and we are ready to test whether the trajectory refuses to bind. We begin with shape. Fit the positions under the sun's pull and you have a small family of curves to choose from. Ellipses close on themselves. Parabolas skim the edge of capture. Hyperbolas bend once, then open forever. Night by night, the residuals shrink toward that third choice. The solution hardens as more stations add their dots. The path is not a loop, it is an exit. Picture a slingshot lane painted on invisible ice. The traveler slides in, rounds the luminous hub, and sails away along a mirror of its entry. The closer the pass, the tighter the turn. But no turn is tight enough if the approach speed is high. Speed decides loyalty. Here, speed rules against adoption. The predicted miss sits well inside the orbit of Mars, bright enough for many eyes, yet the geometry points toward a single visit and a long farewell. Simply put, an open path means it is not from here and will not stay. That single fact carries weight. The rate at which we see such tracks tells us how often other systems throw material into the dark. A one-pass encounter turns the calendar into a scientific instrument, because every hour near the bend is precious. A faster than usual approach pushes us to ask whether we are sampling the high end of a distribution or glimpsing a clue to origin. Contradictions keep the case honest. Could outgassing act like a small engine and fake the extra energy that makes the orbit look unbound? A lively comet can push itself a little with jets, changing the fit, but the light we read is steady within a narrow band, and that calm argues against large non-gravitational kicks. Could early data, sparse and noisy, bias the shape? Multi-site coverage clips that failure mode, because a false open curve would unravel when you stitch together nights from different longitudes and latitudes. The unraveling does not appear. The fit tightens. We look for the breakthrough in comparisons. Place this traveler against the short roster of interstellar visitors already logged. One entered with a brightness that swung dramatically and left arguments behind about shape. Another arrived with a generous coma and an unambiguous tail, a textbook comet from beyond. Our object seems brighter than the first and calmer than the second, with a path that is even more plainly open. The comparison is not trivia. It tells us what to expect from the physics of ejection. Fast entry hints at a violent youth near giant planets, or at long, cumulative trades of energy over ages inside a crowded field of stars. Now the chase turns from pictures to numbers. We translate sky motion into heliocentric components, then into a frame tied to the neighborhood of the sun. We estimate V infinity, the speed far from the sun's grip, a cleaner proxy for what was written into the object before we ever saw it. We measure the approach direction and check whether it aligns with any known streams of stars, because a match would whisper of a birthplace. We propagate orbit clones with tiny tweaks to starting conditions to see how robust the escape remains. We add a non-gravitational term to the model and test whether the data demand it or merely tolerate it. We schedule long runs around perihelion to lock down the bend. This matters because an unbound path gives us a way to test how often planetary systems shed small worlds. It matters because a precise V infinity is a clue to the kind of ejection that launched it, violent or patient. It matters because a clear approach direction lets us compare this traveler with the motion of nearby stellar groups, sharpening guesswork into hypotheses that can be checked. It matters because every clean fit teaches the next survey what cadence and depth are required to catch the next messenger sooner. Questions keep pace with the math. What else could mimic a clean hyperbolic signature if not true escape? Could subtle activity change the orbital energy enough to fool us near the bend? Are we certain that the glint of the crowded plane is not sneaking bias into early measurements? What precision do we need in the next week to push the error bars down to the point where rival explanations lose oxygen? We hold the metaphor steady so the story stays clear. The slingshot lane remains our image. It gives us a single place to stand while we lay tools along the ice. Radar would be too faint at this distance, so we do not count on it. Spectroscopy can still speak if we time it near the peak. When gas lines lift above the floor, narrowband filters pick out dust against continuum, letting us separate material from motion. Photometry keeps beating the drum, hunting for any slow modulation that would betray a shape less round than the calm light suggests. The reveal arrives in pieces, which is how reveals should arrive in real work. The best fit is an open curve with a speed at infinity that is uncomfortably high for a body we would have kept. The bend will take place safely inside the orbit of Mars, bright enough to let a spread of instruments contribute. The departure will not be gentle to our story. It will cut it off. We will have what we have measured, nothing more. And that forces a kind of discipline that serves us well. The energy budget is clear enough to say the sun cannot claim it. The direction is clear enough to ask whether the wider galaxy, not a single named group, is the true well from which it rose. Another set of consequences follows. If we can trust the escape speed, we can place this traveler along a spectrum of ejection histories, from young system chaos to old system attrition. If we can trust the direction, we can ask whether interstellar comets trace the disk the way migratory birds trace a coast. If multiple messengers over years share a pattern, then we can argue for a population map of debris that spans light years, not just a lucky catch here and there. Rhetorical questions mark the rim of what we do not know. Did a giant planet kick this object hard in a crowded nursery, or did time itself, through many weak encounters, add up to the same result? Is our survey work finally sensitive enough to catch the true rate of such travelers, or are we still seeing the loudest fraction? What will the bend near the sun reveal about the surface? If activity rises just enough to let chemistry speak without ruining the orbital fit. We end with a clean horizon line. The track is open. The speed speaks of an origin beyond our yard, and the sun will only edit, not rewrite, the story. The next step is to turn motion into material by reading the light, so we can weigh the core, time the spin, and parse the color that hints at age in the chapter ahead. We turn from motion to matter. The coma is subtle, the tail a thin thread, yet the core holds its brightness with a discipline that draws the eye. The light curve drifts within a narrow band over long runs. There are no sharp spikes, no deep valleys. It is the behavior of a rotator that is unhurried and a shape that is not wildly stretched. Night after night, the pattern repeats. Clue first, photometry stacks into a line that is nearly flat. The amplitude is small, so either the viewing angle is pole-on or the body is closer to round than many comets. Color indices tilt toward red. Such redness often points to organic rich surfaces that have endured long exposure to radiation and micro-impacts. A slow rotation period emerges from long sequences, roughly a day and change, which fits the calm light. This is not a shard spinning itself to pieces. It is a worldlet holding its poise. Now the contradiction. Activity is real, yet the signal is quiet. Vents usually sweep in and out of view and right flicker into the curve. Here the curve resists. Jets could be weak or few, smoothed by a dust mantle that seals most pores. The nucleus could be large enough that minor outbursts get averaged away, or we are watching with the pole tilted toward us, which hides much of the modulation. Which of these is true? How much of the calm is geometry, and how much is geology written in ice and dust? We test hypotheses. If albedo is typical for dark cometary stuff, the measured brightness implies a nucleus of meaningful size. That scale aligns with the small amplitude and slow spin. A rounded body produces small changes as it turns, and a slow period needs long, continuous coverage to reveal itself. Color slopes that skew red can arise from complex organics, tholins formed over eons, and from fine dust that reddens reflected light. Both are marks of age. Surface processing can also build a crust that chokes jets until sunlight warms cracks open near the peak of approach. Think of it like this: a candle under museum glass still glows, but the case muffles the draft that would make the flame dance. Our comet looks like that, a dim ember that proves there is fuel, with the glass of a hardened crust keeping the show restrained. The ember metaphor clarifies two separate truths. There is activity. Because the tail and coma exist, there is restraint. Because the light does not lurch as vents rotate. The chase turns practical. We schedule long unbroken runs to cover more than one full rotation, so windowing does not fake a period. We pair broadband filters with a red-sensitive band to trace color changes, and we add a blue or green band to watch gas lines rise above the floor in case activity wakes up near the bend. We coordinate so at least one observer is always on the object while it is high, knitting a nearly continuous braid of points across many longitudes. We model phase angle effects, because changing geometry alone can make a surface look brighter or redder without any true change in material. Why it matters arrives in 3 strokes. First, a confident size estimate locks down mass and surface area, which sets the scale for outgassing forces that could perturb the orbit. That protects the trajectory fit. Second, color tied to rotation tests. Whether one hemisphere is fresher or dustier, which sharpens the story of how the surface was built and sealed. Third, a slow period tells us about internal strength and shape, placing this traveler among the sturdier small bodies rather than the fragile splinters. More questions keep the pace honest. Could the nucleus be elongated but aligned so conveniently that we mistake it for round? Are we reading a true surface color? or a blend of dust and gas that shifts with activity we barely resolve? If the crust is old and thick, will the approach to nearest sun wake it enough to change the story at the last moment? What change in amplitude would persuade us that geometry, not geology, is doing most of the work? We refine the model. Phase functions are applied to remove the brightening that comes purely from the changing angle between Sun, comet, and Earth. Once corrected, the remaining trend is what the comet actually does. The residual still looks steady, so the slow rotation and modest shape variations remain the best fit. We check for small periodic color swings. A real swing would hint at patches with different grain sizes or coatings, the sort of pattern you get when a crust has only a few weak spots. This has consequences for how we search next time. A traveler can be bright without being flashy. Surveys that rank candidates by drama can miss quiet strength. By learning that a slow, red, stable signal can belong to a large interstellar comet, we tune future filters and cadences to favor endurance over spectacle. That increases the odds that the next messenger will be logged earlier and followed longer. A human step keeps the scene grounded. Picture the chart recorder equivalent on a laptop, a line crawling across the screen as the night softens toward dawn. Every few minutes, a point lands right where the fit expects it. The relief is real. The satisfaction is quiet. The team chat fills with small confirmations rather than big exclamation points. The work feels less like a chase and more like listening for a heartbeat that never panics. One more layer of meaning settles in. A red, slow-turning core is not just a category. It is a history. It suggests a birth in a cold ring far from a parent star, a long tenure under faint light, and a violent ejection or a patient one that did not shatter the body. It points to ages long enough for surfaces to seal and colors to deepen. It hints that even after crossing gulfs, the interior keeps a record that light alone cannot read, but light can lead us to ask for. We are ready for a reveal that is not a drum roll but a door opening. The size is likely on the larger side for such visitors. The surface is likely old and muted. The rotation is slow enough that the skin does not blur into confusion. This combination makes it ideal for a clean experiment near the sun. If activity rises a little, chemistry will speak. If activity stays modest, dynamics will stay clean. Either way, the core will tell us a story that connects surface to speed. We close by returning to the glass-cased ember. It does not flare when you clap. It does not fade when the room goes quiet. It simply keeps its glow as it moves through. That steadiness is not boring. It is a gift. It lets us weigh the core and time its turn with confidence, then carry those facts to the question that waits next. The one the galaxy writes in numbers more than in light. The origin that is encoded in velocity. A passport sits on the table of the mind, its pages stamped by ancient ports. Velocity is the ink. Every entry and exit leaves a trace in speed and direction, and those traces survive long after colors fade. Our traveler carries such stamps in the number that matters most here. The speed it keeps far from the sun. The V-infinity that belongs to its birth and not to this brief visit. Read that number carefully and you read a biography in motion. In plain terms, the faster a body is when the sun is far behind it, the more energy it was given by the place that launched it. Young systems can grant that energy in loud ways. Through close encounters with giant planets that throw small worlds outward like stones from a sling. Old systems change speed in quieter increments, adding and subtracting through many weak encounters, through tides from passing stars, through the slow stirring of the galaxy itself. The same final vinfinity can arise from either life story, so we compare other clues to choose. Direction helps. If the approach lines up with a known stellar stream, we might be watching debris that shares a family motion, if it matches the general drift of the local disk. The birthplace could be almost anywhere among the billions of ordinary suns. The current fit points more to the galaxy's hum than to a single choir section. That does not settle the question, but it keeps us honest about what we can and cannot name. Speed sets the scale of violence or patience. A very high vinfinity suggests a strong kick, the kind you get when a young giant planet flings a small body outward before the system settles. A moderately elevated V infinity can result from the long arithmetic of time, where many small exchanges add up, which is more likely here. The calm light and slow rotation argue that this nucleus has not been shattered recently. That leans, gently, toward age rather than recent upheaval. Comparison tightens the frame. Put this object next to earlier interstellar visitors. One was faintly lit and erratic in brightness, inviting shape debates that never quite closed. Another wore a generous coma and an unambiguous tail, a textbook comet from beyond. Ours is brighter than the first and calmer than the second, and its path is even more plainly open. It sits high on the speed ladder but does not behave like a fragment fresh from a collision. That pairing, high speed with quiet surface, is a tell. This matters because velocity is a fossil that survives the trip across gulfs of space. It carries less prejudice than color or coma, which can change with sunlight, angle, and dust. This matters because a clean measure of V infinity lets us sort ejection stories into bins we can model, young chaos and old attrition, and weigh which bin fills faster. This matters because a good population model tells us how many such bodies should cross our sky each decade, and thus how to build surveys that will not miss them. Questions keep the heat on. Could subtle outgassing near the bend be adding just enough push to fake an older speed? Are we certain that the fit, no matter how tight, is not being trimmed by a shared bias in the way many sites reduce their data? If we wait for the departure and measure again, will the same V infinity greet us on the far side? What precision in timing and astrometry will make that check unambiguous? We step back and use a broader map. In stellar dynamics, there is an age-velocity relation. A rule of thumb that older star populations have larger random speeds relative to the local standard of rest. We cannot assign a birthday to a comet the way we can to a star. But the galaxy does not keep two sets of physics. If a small body spends eons in a disk that slowly stirs, its random motion will tend to grow. Apply the logic carefully. Admit the uncertainties clearly, and a range emerges. The speed and direction we measure are most consistent with an origin several billion years in the past, perhaps even before our sun began to burn. The reveal lands not as a shout, but as a held note. By reading the excess speed that belongs to its birthplace rather than to our sun, and by comparing it with the calm of its surface and the drift of its approach, we infer an age measured in billions of years, likely somewhere between 3 and 11. A timeline long enough to predate our neighborhood and to remember ports we will never see. If database stories help, like and subscribe to the Quiet Universe channel. Now the chase becomes an audit. We propagate many orbit clones with tiny nudges to the start conditions and ask the same question of each. Do they all escape with roughly the same V infinity? We add a non-gravitational term where the data demand it and watch whether the conclusion moves by less than the error bar. We hold back from naming a parent system because the sky has not granted that luxury. And we say so out loud. Evidence is suggestive, not conclusive, and that is a strength, not a weakness. More consequences follow. If this speed is typical rather than extreme, then interstellar comets may be older and calmer than our first samples led us to expect, and survey designs must favor long, steady integration over short, flashy clips. If this speed is on the high tail, then we have seen a messenger from the rarer end of the distribution, a hint that young chaos still speaks across the galaxy and that we should be ready to catch others with similar stamps. Either case pushes us to compare, to verify, and to share data in real time so no single night is wasted. Human scale keeps the edge. Picture a plot of residuals sagging towards zero as new points land right where the model asked them to. Picture the email that says the outbound speed, measured after perihelion, matches the inbound result within the quoted errors. The room does not cheer. It exhales. The number has survived its trial. One last set of questions opens the door we will walk through next. If age is encoded in velocity with this much force, what does that say about memory and time in a universe where motion never truly stops? How does reading a speed become a way to read ourselves? The limits of our patience, the reach of our tools, the kinds of stories we believe, when noise is high and signals are thin. What does a passport of motion reveal about home? We will carry these answers, and their careful hedges, into the final movement, where numbers give way to meaning and the quiet message of this traveler is weighed against the measure of being itself. The comet has already left its verdict on our instruments. A line that does not close. A speed that belongs to a birthplace we will never see. A surface that glows with restraint. We gathered numbers while it crossed our sky, and the numbers rearranged us. They taught us that escape can look serene, that age can move quickly, that a quiet light can carry an archive. We now stand in the wake of its passing, looking at ourselves through the hole it cut in habit. Our calendars felt small beside a clock that counts in stellar turns. Our maps felt local beside a route that ignores borders. For a moment, our machines and our patience were just long enough, and that made the sky feel larger, not smaller. What does a single messenger prove? Not everything. What does it change? Enough. To put it another way, the traveler never spoke our language, yet our measurements let us listen. We did not touch the nucleus, yet we weighed it. We did not see the nursery, yet we read a hint of its climate in color and calm. We did not watch the ejection, yet we inferred the shape of the sling from the speed that survived the crossing. Knowledge arrived as a narrow beam and widened into a room we could walk through. There is a discipline here that we rarely name. Evidence first, story later. The curve of the path set the grammar. The light curve chose the tone. The modest tale gave nouns to the sentence. Dust and gas, pressure and wind. Every time we felt the tug toward romance, the sky answered with a number, and the number was enough. When did we last allow quiet facts to lead our sense of wonder? When did we last accept that a restrained signal can be the most generous? Yet meaning remains our task. If motion writes origin, then we are readers in a library that has no walls. A traveler from before our sun wandered into our night and left us one choice. Believe that chance delights in cruel timing, or accept that the galaxy is full of such pages. And we are only now learning where to look. Which belief makes us better observers? Which makes us more careful with time, more patient with error, more ready to share the sky? There is a human scale to this, and it is not small. Someone tightened a mount in cold wind. Someone tuned a code that caught a faint rise from noise. Someone asked a better question after a worse one failed. The comet does not care, but meaning always passes through hands like these. If a single citizen frame can shore up a professional arc, what else can common attention rescue? If a single precise timestamp can clarify a theory, what else can humility unlock? The comet is gone, and yet it is not. It persists as a set of relations we can keep testing, a speed that can be compared with the next visitor, a color that can anchor a spectrum of surfaces, a rotation that can be weighed against families of small bodies near and far. Patience makes that persistence real. We measure again and again. And the galaxy allows the repetition, because repetition is one of its root languages. We should confess one more thing. Our questions grew better when we stopped trying to summon drama and started tracing what the object refused to do. It refused to be captured. It refused to flash with chaotic light. It refused to answer to a single birthplace we could name. In that refusal, we learned what kind of measurements matter. Clarity is a kind of quiet. Quiet can be a kind of proof. Near the end, we return to the simplest image. A coal, red in starlight. A thread of dust aligned with sunlight. A trajectory that bends and does not return. That image is not a conclusion. It is a compass. It points to a way of looking. Take the thing the sky gives you. Test it. Refuse to overfill it. Let meaning arrive at the pace of evidence. We keep what we measure, not what we imagine. The dome is shut now. The ridge empty. The track cold. But the room where the data live is warm with a different light, a light of comparisons and care. A traveler came, and we listened well enough to learn more about home than about the traveler. Perhaps that is always the deepest prize. The final scene is simple. A quiet lab, a map with one more open line, a night that ends without applause. As the planet turns and the galaxy keeps its slow music, what else is already crossing our field? Too small to notice now. And how ready will we be when it writes its signature across our sky?